When we want to graph using the slope, we don't need to start from the y-intercept. We can start from any point we want to. In the last video, we were trying to graph the equation y equals 2/3 x minus 5/3. What we'd really like to find is a point that has nice coordinates. And the way that we want to do that is by trying a whole bunch of x values and seeing if any of them give us a nice y value. And we could do that by hand by making a table. Or, since our equation is solved for y, we could make a table on the calculator. I'll show you making the table by hand, and then show you doing the same thing on the calculator. So, I'm going to have some x's and find the corresponding y's. I happen to like positive numbers, so I'm going to choose positive values of x. When x is 0, of course, y is negative 5/3. When x is 1, I'll have 2/3 minus 5/3. Oh, hey, that's nice already. We have y is negative 1. The point 1, negative 1 is on our graph. Okay, we're pretty much ready to set up our axes. Of course, we want to make sure 1, negative 1 is on our graph. Let's see. Making sure that we have enough space for all of our interesting features. I'll make a table and put 1, negative 1 in the middle row. The change in y is 2. The change in x is 3. So for our x's, we will add 3 and get 4, subtract 3 and get negative 2. For our y's, we will add 2 and get 1, subtract 2, get negative 3. So our x-axis has to show all these numbers. Our y-axis has to show all of these numbers. So our axes might look something like this. And I extended the y-axis a little bit further up than it had to go because it looked nicer that way. But we'll plot the point x is 1, y is negative 1. Using our slope, we'll go over 3, up 2. Here's our second point. And now we're ready to sketch our graph. As you can see, neither our y-intercept nor our x-intercept are particularly nice numbers, but we could still find nice points to use to draw our graph by taking a little bit of care. Now let's see an example where a nice point is a little bit harder to locate, and we want to use our calculator. Let's say we want to graph 5x plus 9y equals 21. If we find the intercepts, we'll immediately see that we get unpleasant numbers. They're 21/5, 0 and 0, 21/9. We don't want to be bothered with that. So maybe it would occur to us to use the slope-intercept form. We'll solve for y. 5x plus 9y is 21. We'll subtract 5x on both sides, and we'll get 9y is negative 5x plus 21. Multiply both sides by 1/9, and we'll get y equals negative 5/9 x plus 21/9. And we could simplify 21/9 if we liked. 21/9, there it is as a decimal. There it is as a fraction, 7/3. But that's not really a whole lot better, is it? I could go through by hand and find a whole bunch of xy pairs until I got whole numbers. But you know, 0 7/3, negative 5/9 times 1 plus 7/3, 16/9, 1, 16/9, negative 5/9 times 2 plus 7/3, 11/9, 2, 11/9. I think I might be at this for a while. Instead of doing these tedious calculations myself, I'm going to have my calculator do them. I'm going to go into y equals, clear out what I left lying around, put in negative 5/9 x plus 7/3, and then hit second followed by the graph button to look at the table. Hey, the place that my table's set happens to have a nice pair. Do I see anything with smaller x's? There's another one. Right, I could use negative 3, 4, or I could use -6, -1. I can use whichever point I prefer, or I could just use both of those points. I think I'm just going to use both of those points. I'm going to draw my axes. So I'll draw some axes that look like this. Again, making y a little longer to make the graph prettier. I'll plot my negative 3, positive 4, and I'll plot my positive 6, -1, connect those, and I get my graph. So one thing to note, if you happen to find two nice points, you can just use them to graph.